The next question is from Thermodynamics for 2 marks. 1 kg of air in a closed system undergoes an irreversible process from an initial state of P1 is equal to 1 bar absolute and T1 is equal to 27 degrees centigrade to a final state of T2 is equal to 3 bar absolute and T2 is equal to 127 degrees centigrade. If the gas constant of air is 287 joule per kg Kelvin and the ratio of specific heats gamma is equal to 1.4, then the change in specific entropy in joules per kg Kelvin of the air in the process is. So the 4 options are given, and according to the official key, the correct answer is option A. Let's move on to the detailed solution. From the question, it is known that the mass of air is m is equal to 1 kg. It is also given that the closed system undergoes an irreversible process. It is given that the gas constant of air is R is equal to 287 joule per kg Kelvin. It is also given that the specific heats gamma is equal to 1.4, and we know that specific heat at constant pressure for air is 1005 joule per kg Kelvin. The initial conditions and final conditions of the air are given, where the initial conditions are P1 is equal to 1 bar and T1 is equal to 300 Kelvin. Final conditions are P2 is equal to 3 bar and T2 is equal to 127 degrees centigrade. Converting that into Kelvin will give us 400 Kelvin. And we are asked to calculate the change in specific entropy, which is delta S is equal to S2 minus S1, that is specific entropy in the final state minus specific entropy in the initial condition. Since we are given with pressure and temperature values only, we can express the change in specific entropy as delta S is equal to Cp ln T2 by T1 minus R ln P2 by P1. We know the value of Cp, which is 1005. We know the value of T2, which is 400 Kelvin. T1 is equal to 300 Kelvin. We know R is equal to 287. P2 is equal to 3 bar and P1 is equal to 1 bar. Just substitute all the values, and simplifying that will give us specific entropy as minus 26.3 joule per kg Kelvin.